using basic ideas, discussion in class. We will make some fundamental concepts. Few things can be written, like for a reference, like a checklist and what we have done. Detailed notes can be made from the digital side, and you can memorize in physics. Obviously, some definitions have to be memorized. There are sketches, there are theory working. So we are starting from here in our formal introduction that in a formal way, because this is the first thing to discuss always. This is the syllabus code 4PH1. You can confirm this code if you know it, or you can later confirm it. If the code is different in Edexcel, the syllabus is not much different, but normally the main ideas are the same. In region wise, there are some different options available. This is IGCSE 921 4PH1. So can you confirm, is it the same code or?
It's the same.
Okay. Now, this is the topic list: forces and motion, electricity, waves, energy resources and energy transfers, solid, liquids and gases, magnetism and electromagnetism, radioactivity and particles, and astrophysics. This is the first thing to see. There are 8 units in our chapter, in our course: forces and motion, electricity, waves, energy resources, solid liquid gases, magnetism, electromagnetism, radioactivity, and astrophysics. Teachers normally do not follow this sequence. For example, I teach electricity with magnetism and electromagnetism because they go together. Astrophysics can be discussed in the end. And when school is planning to take a mock in January, then obviously they will be taking everything, in my opinion, except maybe 1 unit or 2 unit may be neglected, or maybe just like you can give me an idea that are they going to test everything in this list, or?
I'm pretty sure they'll test everything because the mock we had a few weeks ago, they tested everything except for magnetism and radioactivity.
Acha, okay. So it means that they have actually finished the whole course.
Almost, yeah.
Good. So that's fine. So that is the normal case with all schools. Some schools have 1 chapter left, so they put it because you people are already sitting for some exam. So this is a case which normally does. So this is the first paper. This is a 2 hours paper and 110 marks. This paper is the first paper. It's relative to paper 2. It's a primary paper. Some concepts are exempted here. Otherwise, syllabus is everything is coming. But some concepts which they have printed in bold, that do not appear in the paper 1. Normally, people consider that in teaching language that paper 1, paper 2 are syllabus-wise same, but paper 1 is less intense. Paper 1 is like a scoring paper. It's a bit lengthy paper. Second paper is 1 hour 15-minute paper, and syllabus is the same, but it is more intense paper, more detailed theory is required. But obviously, the 2 papers are tested in the same session, so there's not much difference in preparation. You have to prepare both the things together. At the time of paper, when you prepare, so you can take something like you can score more in paper 1 easily. Now, this is the basic introduction. As already you are in this subject, so detailed introduction is not needed. So we will be starting with the first topic I'm taking. This will be like a discussion week. I'm taking current of electricity, a very primary topic. As I mentioned that the same pattern will be used. The syllabus content will be discussed. We need to make some concepts. Some things can be written here. And obviously, physics is a conceptual subject. Once you make some concepts and you are able to do some topical past paper, it means the subject is rolling down. As you do more past papers, you will see greater understanding automatically comes. So, not recommending any book. We need topical past papers. We need topical past paper. We need digital notes that we will be sharing here. You can do one thing that you can make a folder and a physics folder in that like other subjects store the things in notes, topical past paper, yearly past paper in that way. I'm starting with the first title, Current of Electricity, and the one liner is the study of moving charges. Electricity is actually right now, even now in this era of artificial intelligence and other things, still electricity is the biggest source of energy. Everything we are nowadays using is electricity. Now, the concept comes here that how this energy is transferred. We have a concept that this energy is transferred by moving charge particles like electrons. So when you press a button and the light comes on, and then when you switch off, the light goes off. This is the transfer of energy by electrons. Electrons are those particles which are charged. They can carry the energy to the target's object and themselves they come back. So when you press a button, there are two wires connecting the object. One is called the live wire and second is called the neutral wire. Electrons take the energy from the source, from the socket board, and they take to the device and themselves they come back after delivering the energy. So this is my socket board and there are two wires connecting from here and this is my device X. Okay. One of the wire, one of the socket board, one of the socket board is basically one of the socket board is the live wire and one of them is the neutral wire. Normally we show the red wire as the live wire which carries the high energy electrons. So we have two sockets here. One is called neutral and one is called live. The high energy electrons travel from the live wire and they reach the device. They offload the energy. They offload the energy inside the device. They transfer energy inside the device and the exhausted electrons go back to the socket board for the next round. It should be considered very similar to a situation when there are some laborers who pick up the bricks, they take it to the target position, offload the bricks, and they come back and they again go for the next round. This is the fundamental concept of this chapter. So we put the introduction. Acha, you give the heading current of electricity, give the one liner study of moving charges. Put the date of today and put the heading current of electricity as our first chapter.
Done.
So this is the title of this chapter. I'm putting the introduction. Electric current deals with moving charge carriers. As mentioned, that actually when you see these electrical wires all around us nowadays, so this is an electrical wire. The copper wires normally inside the wires, these are the traffic, these are the vehicles moving inside these wires. These are charged particles. These charged particles transfer energy, and this energy is called electrical energy. We build our next concept. This will be our second concept, that electric current passes only through conductors. It means everything do not conduct electricity, like plastic, like wood. It doesn't conduct electricity. This is actually a concept of conductors. Conductors, like there are majority solid conductors in our world. Copper is a very common example. But when you have a battery, a liquid battery, not the mobile phone one, it has a solution which is an acid solution coming from the chemistry concept. It can conduct electricity. Normally, gases are generally poor conductors. Normally, gases are poor conductors. That is why lightning from the sky, why it occurs, because gases do not welcome electricity. So they have to struggle, they have to jump here and there, and that is why lightning sparks. What is the best way of studying physics? That when you are looking up sub concepts, try to memorize the concept with understanding, because wording can be changed except the definition. Some wordings are there to be memorized, so that will be obviously coming from the notes. But physics is actually like a concept building. In the exam, the examiner will be connecting it with some real situations, like real conductors, real fire situation, real safety precautions. And that is why teachers use, which I use also, videos, animations. They share YouTube videos also. So physics is actually a subject of visualization and connecting it with the common life. That is why it is like a exposure subject. Electrical conduction in metals in terms of movement of free electrons. This is our third concept for today, that how electricity is able to pass through some conductors only, why everything do not conduct electricity. Now we have a concept that every solid, especially metals, conductor contain free electrons. Now, these free electrons are present inside a conductor. What are free electrons? Actually, these are the electrons which somehow escape from their atoms. They are free to move in different directions randomly, like dodging cars. And these electrons travel in various directions, and they are present in conductors. So free electrons are present inside a conductor. Look at this motion. This is how free electrons move. They're moving like dodging cars. They have actually escaped. They have actually escaped from their atoms. They are moving in different directions. These are called free electrons. Now, free electrons are present in all conductors in different numbers. Some conductor contain more free electrons and some of them less. Now, this is a typical chemistry animation, but it makes a very good concept. This is a metallic bond. Inside the metallic bond, there are free electrons. These free electrons are moving randomly across the crystal. They are the energy carriers. If you provide a positive on one side and negative on one side, what happens? These electrons, which were initially moving randomly, they begin to move in a particular order. It's a very nice understanding concept. If you look at this animation again, presently they are random. Okay, they're moving here and there like dodging cars. Now, you apply a positive potential on one side and a negative on the other side. This is called potential difference. Now the electrons begin to move in a particular direction. This is called electric current. This is called electric current. So the free electrons are present in every conductor, but once we provide a potential plus and minus, these electrons begin to move in a particular order. This is called electric current. We put the definition of current. Electric current is the rate of flow of charge carriers. Look at the symbol. electric current is a scalar quantity. So you have to copy this now.
Done.
What are scalar quantities?
It's a quantity which only has magnitude but no direction.
Good. Now, this is the concept here. These are the electrons which are moving randomly without any particular direction. And once we apply a potential difference, they move in a particular order. Now, formula for current. We put the formula for current. I is equal to Q upon T. This is the fundamental formula where I stands for electric current, Q stands for quantity of charge, and T stands for time. This chapter, current of electricity, is rich in formulas. So normally is rich in formulas. So normally what happens that a lot of formulas come in this chapter. So people use a formula list to memorize all the formulas. Lot of numericals come in this chapter also. Formula for current. So you have to now copy this.
Done.
Okay. Now, SI unit, which is our primary chapter when we start physics, it is I is equal to Q upon T. The unit of Q is Coulomb and the unit of time is second. So it's Coulomb per second. Coulomb per second is equal to CS minus 1. I is equal to ampere, which is the summarized version of the unit. Coulomb per second is C upon S, which is ampere. 1 ampere is equal to 1000 milliampere. Now, normally we use this symbol as micro. How we define ampere? When you have to define a unit in physics, when you want to define a unit in physics, you have to write down the subunit. Like for example, ampere is coulomb per second. So what you do, you write 1, 1, 1, and you connect them by a statement. If 1 coulomb charge passes through a conductor in 1 second, the electric current is said to be 1 ampere. This is how in physics you can define any unit in physics can be defined in this way, provided you remember the derived unit and the base main units. Now we put our next concept. In our physics, sketches are extremely important in few chapters like kinematics, motion, sketches are there. In electricity, sketches are there. Normally, there are two features to remember about a sketch. The first feature says the gradient of a sketch is y upon x. Gradient of a sketch is y upon x. Second important concept is the area. Like here I have shaded the area. So area is the product of the two quantities. Why this area shows quantity of charge? Because I into T is the quantity of charge from the formula, because I is equal to Q upon T. So Q will be equal to IT. So now you have to copy this.
Done.
Right. Now, concept of an electric circuit actually discussed in the start of the class. This is the main feature of the importance of this chapter, why this topic got so much fame. And in every year, this is a very compulsory topic because electricity is actually driving everything for us. Other technologies like which are getting fame now, they are also dependent on that. So every electrical circuit consists of two wires, live and neutral. Now the live wire carries the high energy electrons while the neutral wire take them back, as I explained in the start. So for example, this is a circuit and this is a minus terminal. So electrons will go in this bulb and they transfer energy to the bulb. The bulb light up here because it converts the electrical energy into light energy. Now, after delivering the energy, electrons come back home and they get ready for the next round. This is how electricity is working. That is why there is a two-pin plug in every circuit which make up this connection. In the way you can say that electricity is basically a concept of energy transfer in a loop. This is a very nice animation to simulation actually. It's a very nice animation to show that how electrons are transferring energy. It's just like a water system, which is called hydroelectric water system or or water driven system. In the left side, you will see electrons are moving and they are transferring energy to the lamp. As an analogy, you can see the right hand side, water is moving through the pipe and it is moving the turbine. So water is delivering energy to the turbine and water itself is not being used up, it come back. This is how electricity, this is how electricity works. Now we make our next concept. Charge carriers are energy carriers. For example, electron transfer energy in electric circuits. So you have to copy this concept now.
Done.
Right. Some electrical circuit may contain the third wire, the earth wire. Look at this. This is the third wire, which is the earth wire. Now we talk about electrical energy. What is electrical energy? In physics, multiple energies are there. Heat energy, chemical energy, electrical energy. The energy transferred by moving charge particles. So this is the definition. What is electrical energy? It is the energy transferred by moving charge particles. Now, charge carriers are energy carriers. We already have discussed that. Now, conventional direction of electric current. That's a very interesting concept. Normally, when we talk about electricity, we always consider that these are electrons. So electrons, these are electrons which are negative particles and they are traveling inside the circuit. Logically, how we drive them, we put a negative plate on one side and we put a positive plate on the other side. That is why when you buy a new cell or a battery, you will see a positive polarity mark and a negative polarity mark. This is how a cell pushes or pulls the electrons. Now, this is logical that if it's a negative and this is an electron, due to repulsion and attraction rule, it will move from minus to plus. But in the start of physics, obviously, years and years ago, they that time they considered some basic positive particles to generate current, like in solutions. So at that time, they made a rule that current travels from plus to minus, while electrons travel from minus to plus. From that time, we got a terminology which is called conventional direction of current. Conventionally, current is shown plus to minus, even though in reality, electrons travel from minus to plus. So free electrons travel from negative to positive, but conventionally electric current is shown from positive to negative. This is how we work here. These are called electrons. Look at this. So electrons always travel. This is the original direction. And the conventional direction is this. So conventionally current is shown from plus to minus. So when we run a device, we show in a circuit, current always travel from plus to minus. This is called conventional current. So you have to copy this.
And
Types of power sources. Look at this. Types of power sources, AC and DC. There are two types of power sources, AC and DC. You have to copy this also.
done.
Right. Now, the two types of current are in our common use. AC means alternating current. DC means direct current. In our homes, in the socket walls, in the socket plugs, we have AC. While the portable devices like our mobile phones, gadgets, they use DC. AC is that current which keep on reversing its direction. It doesn't go in one direction. It keeps on reversing. DC, which is coming from a portable cell, it goes in one direction only. So now we talk about a new concept, resistance. The symbol is capital R. So now you have to copy this. What is resistance? The concept of resistance is similar to the concept of friction on a road. When a vehicle is moving on a road, it experiences friction. Friction is like a opposing force. Similar to that, when electrons are moving in a conductor, they come across vibrating atoms. Now, these are called electrons. Their motion is called current. Current is like traffic of electrons. So, this is the main concept. So, when these electrons are moving, they come across vibrating atoms. These atoms are vibrating on their mean position and they disturb the moving electrons. This phenomena is called resistance. So, what is resistance? Resistance is the opposition. Resistance is the opposition offered by resistance is the opposition offered by offered against the motion of the free electrons. Now, basically, whenever you talk about free electrons are already present in a conductor. We do not provide them, we just move them. This is just like inherited property. And this is a Java application, and this is a very good website. I will share it, inshallah. This is a very good website to explain the important and difficult concepts of physics. Now you can see the blue marbles are electrons. The blue marbles are electrons, and the green jumping balloons are the atoms. This is the source of resistance. Presently, the conductor is hot, cold. And if we increase the resistance, let me increase the resistance, you will see now there are more atoms jumping in between. This is called a greater resistance. So resistance is basically an opposition against the flow of electrons. These balloons, these atoms disturb the flow of electrons. And you can always see that if I suppose I'm reversing the voltage, look, when I reverse the voltage, what happens? Electrons reverse their direction because voltage is the driving force of these electrons. These electrons get exhausted, they go inside the battery, they get charged again, they take up energy, and they come out with the energy and go for the next round. Now, our next concept. Due to resistance, some of the electrical energy converts into heat. This is called heating effect of current. That is why every device, even a small gadget, even our iPads, some heating always occur. Some devices heat more than the others. That is why when you are running a laptop, there is a fan on one side which is emitting the heat. Why? Because due to resistance, some of the electrical energy converts into heat. This is called heating effect of current. So now you have to copy this. Okay, you have to copy this.
Done.
All electrical devices heat up when they are in use. Now, in some cases, we do not want the heating. For example, your mobile phone should not be heated. Some people even use special apps to cool down the mobile phone if it gets heat up. In some cases, like a toaster, like a hair dryer, we want heating to occur. A room heater, obviously, is designed to generate heat. So the game moves around the word resistance. Our next concept. Resistance of a conductor never zero, even if the device is off. So if your home device is off, resistance is not zero. Why? Resistance is the capacity. It is just like moving, jumping atoms. So they are always jumping. This is the atomic structure concept. So resistance is always present. What are the factors which control the resistance? The factors which control the resistance are temperature, cross-sectional area, length, and nature of conductor. These are the important features which control the resistance. You have to copy this.
Done.
Right. Now, effect of temperature. I'm putting the first title. When you have a pure conductor, what's a pure conductor? Like copper, silver, they are pure conductors. When you have a pure conductor, the resistance increases as the temperature increases. Why this happens? When you are dealing with a pure conductor, when you're dealing with a pure conductor, there are obviously vibrating atoms in them. When you increase the temperature, when you increase the temperature, these atoms vibrate more energetically. In that sense, what happens that they disturb the electrons more, like people moving on a road. If they are moving in a big number, they will stop all the traffic. So similar thing happen here. So these atoms vibrate more energetically. Resistance generate heat. Acha, this is to understand that how temperature is a factor, because normally we do not heat up our devices. Obviously, no one will actually heat up his mobile at anything like that. Actually, electrical devices are responsible for their heating themselves. They create heat. So mobile phones, gadgets, they create heat. So resistance creates heat. Heat creates temperature, and temperature actually increases resistance, which goes on like a vicious cycle. So resistance creates heat, heat creates temperature, and temperature again go back and increase the resistance. So now you have to copy this concept sequence.
Done.
Okay.
Sir, I have a question.
Yes, please go ahead.
Heat and temperature, they're like two separate things, right? Because could we say heat is also thermal energy, and would
Hmm.
temperature be like a different definition or something?
In O-level physics, in our IG physics, heat and temperature are mutually related. We say that temperature is a scale to measure heat. It's a measure of average kinetic energy of molecules. Internally, that's right. Temperature and heat are different things. But in our normal chapters, we say that when you heat up something like a conductor, its temperature rises. So when your mobile phone is gaining heat, its temperature will rise. Human body has a different function. Some other cases, this definition obviously get denied, but normally in physics we say that heat is expressed as temperature. Definition wise is different. Heat is a measure of total kinetic energy of molecules. Temperature is a measure of average kinetic energy of particles. Here, how they are connected? Here we have a concept that resistance generates heat and heat generates temperature. Temperature go back and it again support resistance. So it's like a connected effect. Now, for the safety of the device, we put our next concept. For the safety of the device, there must be a good cooling system, but otherwise heating can damage the device. Cooling system may include exhaust fan, black metallic fins, liquid cooling, and different options are there. This is the outer unit of those conventional split air conditioners, and this outer unit contain a big fan. The purpose is to keep the system cool. So in this system, temperature of the device becomes stable after some time. At this point, the resistance also becomes constant. Now look at this graph. Resistance increases as a pattern, but if the cooling system is working, resistance becomes constant after some time because we are controlling the heat transfer. So if we have a good cooling system, resistance initially increases, but then it can become constant. Now, change of resistance is a very important concept which comes lot of times in our exam. And this is the concept that resistance keeps on changing if temperature is changing. Now, the devices that use the heating effect of current, like electric kettle, it uses electrical system heating. Iron has the heating effect of current. Room heater uses heating effect of current. Now we talk about filament. Actually, filament is used to generate heat in heating systems. Like you can say, you can talk about what you can talk about. You can talk about these iron room heaters, hair straighteners. They all contain filament. They have a high resistance which convert electrical energy into heat energy. Filament looks this like. This is the way they look like. When they're on, they are red glowing wires, like in toasters, like in other things. So now you have to copy this.
Done.
Right. Filament lamp is a very important apparatus. Filament lamp is a very important apparatus in our knowledge for it's a very important apparatus for generating light. It's not very common now. It's an obsolete but a very important topic of discussion. It contains a filament which is normally coiled so it can fit inside the bulb. And this is tungsten, an element which can withstand high temperature. These are called yellow light bulbs. Now they are not common because of their very, very low efficiency. People do not like them because their light is yellow. The filament glows. Why they glow? Because they stop the electrons. As they stop the electrons, they can generate heat and light. Now, a filament creates heat, light, they have high resistance, high melting point, and this is a thin and long wire. Now, give the heading semiconductors and temperature.
Done.
Right. Look at this. What are semiconductors? They are somewhere between good conductor and good insulator. Semiconductors are famous because they come in the use of electronic devices, these gadgets, these computers, they all use semiconductors. Semiconductors are those devices which are somewhere between good conductors and good insulators. What is their behavior of their resistance? Resistance of a semiconductor behave differently, not like a pure conductor. The resistance decreases as temperature increase. Now, this is a special effect. Acha, all semiconductors do not do that. We have a limitation in our chapters. So we say that resistance of a semiconductor decreases as its temperature increases. So examples of semiconductors are LDR, thermistor, and diode. These are the famous names of semiconductors. Now you have to copy this.
Done.
Now these are called semiconductors. In a semiconductor, there are some limited free electrons, and free electrons are moving. When you increase the temperature, number of free electrons increase. They get more electrons which are moving freely. So in a semiconductor, there is a limited number of free electrons. So when temperature increases, free electron increases. As a result, current increases and resistance decreases. Now, introduction to sketches. This is a topic which actually covers a lot of other chapters also. Wherever you come across sketches, even in all other chapters, this will be a general support. So you have to give the heading Introduction to Sketches.
Done.
Right. Now, these are the primary knowledge for the sketches. If there is a straight line passing through origin, it is called directly proportional. If the line is straight, but it is not passing through origin, it is called a linear function. And this where the line is a curve, not touching any axis, it's called inversely proportional. So you have to copy these three sketches.
Done.
Okay. So now we put our concept directly proportional. Directly proportional comes a concept from maths. Directly proportional means if one quantity doubles, other quantity also doubles. If one quantity becomes half, the other quantity also become half. This is called directly proportional. It has a constant ratio. So when x is proportional to y, when x is proportional to y, x is equal to ky, x upon y is equal to k, where k is a constant. The ratio becomes constant. Look at this 3, 2. Now you will notice that 3 upon 2, 6 upon 4, 9 upon 2, all the ratios, all the time the ratio is constant. What is inversely proportional? Inversely proportional means if one quantity is doubled, other quantity is halved, and x into y is equal to k. This is the product which is constant. So inversely proportional is a case where one quantity increases and other quantity decreases in the same proportion. Like here, the product is constant. Normally, inverse proportionality is a case when the two quantities are moving exactly in opposite ratio. So we have done till here that we have discussed the basic idea, we have discussed the introduction, we have made some concepts in current, and we will follow it in the same pattern in an ordered way as we maintain a register, digital notes, topical past papers. Yearly past paper, if do you have a school book, yearly past paper book from school?
Not yet for physics. They'll give it to us like near the exams.
No problem. Then we will use digital as we did there. But because if you have, I think you have the pen and tablet, so we can save the printing cost and we can solve on it. And once they give it, then obviously, because obviously when they are giving it, then I think it would be compulsory to take the book. So we will stop here and we will inshallah continue in our next class. Allah Hafiz.
Allah Hafiz.